The following video is about linear programming. The first thing that we're going to talk about are some helpful tips to do linear programming. And then as we do the problems, it'll make a little bit more sense. Number one, define your variables. Number two, determine your objective function. That's the thing that you're trying to optimize or maximize or minimize, basically. Number three is to determine your constraints. Those are the things that limit you in your ability to do things in a particular context. Number four is graph the constraints and determine what the intersection points are. And then number five, determine the intersection point that optimizes the objective function. So essentially what happens in linear programming problems is you have two variables that you want to figure out what's the best way to utilize these two variables in order to get a maximum or a minimum of the thing that I want. Maybe maximize profit, minimize cost, maximize your test score, uh, something like that. And we use linear inequalities in order to figure those out. You're about to take a test that contains questions of type A worth 4 points and of type B worth 7 points. You must answer at least 5 of type A and 3 of type B, but time restricts answering more than 10 of either type. In total, you can answer no more than 18. How many of each type of question must you answer, assuming that all of your answers are correct to maximize your score? And what is the maximum score? Use the graph provided and solve the problem using linear programming. So the first thing we want to do is define our variables. Uh, Usually what I do in order to define the variables is I look at the question. So how many of each type of question must you answer, assuming that all of your answers are correct to maximize your score? So the question mark indicates that that's really going to give us a hint as to what our variables are. And in this problem, our variables, we can make them X and Y or whatever, but I'm going to make them A and B just to give you some practice with something that doesn't have X and Y as the variables. So A would be number of type A questions, and B is going to be number of type B questions. So that's what we have going on for defining our variables. And then the next thing that we're going to do is determine our objective function. So the objective function is the thing we're trying to maximize or minimize. So we want to maximize our score. So if we want to maximize our score, I'll make a function that we're trying to maximize or minimize here. And I'm going to call it S, and it's a function of both A and B. I'll call it S because it means score, but I could call it whatever I wanted. I could call it P or W or whatever. So S of A comma B is going to be 4A plus 7B. The reason why that ends up being what I'm trying to maximize is I know that my score is going to be 4 times the amount of type A questions that I get right and 7 times the amount of type B questions that I get right. So I just take the information that the problem gives me about my score and I put it as a score function. Next, I want to determine my constraints. So these are the things that limit me. And basically everything else in the problem is a constraint. We must have at least 5 of type A and 3 of type B. So A must be greater than or equal to 5, B must be greater than or equal to 3. Time restricts answering more than 10 of either type. So A must be less than or equal to 10, and B must be less than or equal to 10. Also, we cannot answer more than 18 total questions. So A plus B must be less than or equal to 18. So if I take all of this information, I now want to put this on the graph. So my constraints are what I graph. I'll make A and B the axes. I want to go up by ones. Well, at least in this problem, I want to go up by ones. And I want to get to 18. And the reason I want to get to 18 is that is something that I use in my constraints. So I now have everything labeled enough where I can graph this effectively. So if I look at my A restrictions, A must be greater than 5, greater than or equal to 5, less than or equal to 10. So I graph greater than or equal to 5, less than or equal to 10. Once again, if it's greater than X, it would go in that direction. And if it is less than X, it would go in that direction, or in this case, A. So greater than A, less than A. So it's basically in between these two vertical lines. Now I'll take the B values. So B must be greater than 3 and less than 10. So essentially what I have going on here is, in order to meet all of these criteria, it must be inside of this rectangle. But we also have one more thing that we have to take into account, and that is we have this other constraint, A plus B is less than or equal to 18. So that is a line that has A and B intercepts at 18. And if I graphed this, it would end up being a slope of -1. So I'm going to carefully graph this where my slope is -1. And that's something that it looks like. Yes, I have a dip, but sorry. It is super important that you graph it accurately. So graphing accurately is huge because I have to determine the intersection points correctly. Now, something that's kind of important after I shade in my region here is that the correct answer is going to be at a vertex of my shaded region. So the only possible answers in any linear programming problem are the vertices of the shaded region. Let's talk about why really briefly. If I take any point on the inside of my shaded region, if I want to maximize it, if I want to maximize this function, if I moved to the right or up, I would increase my score. If I wanted to minimize that function, if I moved down or to the left, I would decrease my score. So no matter whether I wanted to maximize or minimize my function, any point on the inside would definitely give me not the maximum or minimum. Likewise, if I picked a point on a line, if I wanted to maximize, I would move to the right, and minimize, I would move to the left. So once again, in either case, there's no reason to pick anything other than a vertex. Vertices are always either going to maximize or minimize opportunities, at least along the line. And just from a logical perspective, these two are the only ones that even have a chance of being the winner, because since I'm trying to maximize 4a plus 7b, if I picked this point that I'm the point 10.3, I clearly could get a better score if I moved up. I'm going to check all of them at this point because the rules are that the fundamental theorem says that anything that's a vertex is a possibility, but I'm pretty sure that both of the purple circled points are my only options. So let's just check all of these answers. So S of 5 comma 3, if I substitute in 5 for A and 3 for B, I get 41. That is clearly the minimum score that I could get. S of 10 comma 3, if I substitute that in, I get 40 plus 21, which is 61. S of 5 comma 10 will give me 20 plus 70, which is 90. So that's clearly a lot better, but it's still probably not going to be one of my winners. So the two that I thought might be winners at the beginning are S of 8 comma 10 and S of 10 comma 8. If we're being logical about it, this one is probably going to be the winner because B gives us a higher point value for every B question that we get right than A questions. And in this one, we're answering more B questions. So I'm assuming that this is going to give me a better score, but let's just double check. 8 times 4 is 32 and 7 times 10 is 70. So my score would be 102 if I answered 8A and 10B correctly. And if I do 10 and 8, I get 40 plus 56, which is 96. So S of 8 comma 10 is going to give me the best score. So to answer my question, I would say my maximum score is 102, and that occurs with 8A questions and 10B questions. So that would be answering everything that they asked me to talk about. Second question. Christian plans to invest up to $22,000 in banks. You can read the rest of it. Okay, let's talk about defining our variables. So how much should he invest to maximize the income in each bank? So that means our variables are probably investment in each bank. So I'm going to make X, I'll use X and Y in this case. So X would be the investment or the amount of money in, let's say, BMO Harris. And then Y can be the amount of money in First American Bank. So that will be my X and Y here. Determine my objective function. So my objective function is going to be the function that maximizes or minimizes the thing that I want to optimize. So I want to maximize income. So let's call it the income function. And it's a function of X and Y. It looks like the income that I'm getting is from interest. So if I get 4% interest from BMO Harris, it'll be 0.04 times X plus the amount of interest I get from First American, which will be 0.035 Y. So this is what I want to maximize and minimize. Determine my constraints. So figure out what limits me. So if I'm taking a look at the constraints, what I end up with is I have several constraints. He wants to invest up to 22,000 in the banks. So this is the amount of money that I've invested in the bank. X plus Y can be no greater than 22,000. Since all of these are in thousands, I can probably just get rid of the 3 zeros as long as I remember to put it in at the end of the problem. So that's kind of what I'm going to do. He must invest at least $2,000, but no more than $14,000 at BMO Harris. So X must be greater than or equal to 2,000, which I'm going to write as 2, but it must be less than or equal to 14,000, which I'm going to write as 14. And he will invest no more than, so less than or equal to 15,000, which I'm going to write as 15. So these are my constraints. I will graph them. I probably, since my graph only goes up to 20, I would probably want to maybe go up by 2s. So thanks for your patience as I write the lines down there. So X must be greater than or equal to 2. X must be less than or equal to 14. Y must be less than or equal to 15. So that's kind of a dangerous situation we got going on here. I have to be really careful about graphing this accurately. And then I have something with a slope of 1 going all the way down. Like this. So I look at my intersection points. And here's my shaded region. So this is something that I have to take into account. I want you to try each of these points and see if you can answer the question. As you can see, The intersections are as such. If you had a hard time figuring out that 715 was an intersection, you can figure that out by the fact that this is the line y equals 15. And if you substitute it back into the constraint that this line represents, the diagonal line, you can see that x plus 15 less than or equal to 22. If you solve, you figure out that x is 7. So that's how you get there. I just substituted things into everything and figured out that 14 comma 8 is the best answer that maximizes our income at $840. And so I answered the question as such in blue down here. Now, this was also probably my best guess. So my best chances were these two because since I'm maximizing something that has all positive numbers, I probably want to be as up and to the right as I possibly can. So these two green circled points are my best chances. And this is my best guess because if I look at my function, x is worth more than y. So because the 0.04 is greater than the 0.035, that means that my x is more valuable than y. And so 14 comma 8 is likely to be the correct answer, more so than 715, but I just double checked them anyway.